Good evening, everyone, or good afternoon. How are we all feeling? We had a good serverless days? It's been pretty fun, right? Awesome. I am the thing that is standing between you and beers, so that's an incredible amount of responsibility and power, which I will abuse as much as I can. No, I'm joking. Welcome to my talk, Building Serverless Applications with Azure Container Apps. Now, quick question. Who here is deploying any kind of workload to Azure? That's more than I expected. That's awesome. Cool. So you'll be able to fact check me and make sure, oh, that's right, that's wrong. How many of you aren't touching Azure at all? Okay. Okay, fair enough. Awesome. It will come? It will come? Yeah, we'll convert you, maybe. So just a little, if I turn that on, that might help. It was on. It's not going to work, never mind. I'll just use the clickety-clack. So who am I? I am a lead software engineer at Mantle Group. I'm living in Melbourne, but I used to live in Auckland for 13 years. Moved to Christchurch straight out of high school, played rugby for a little bit. I was too good at that compared to you Kiwis. You Kiwis aren't that great at rugby. No offense. No, I'm just kidding. Can't really say that as an Englishman. That's a horrid thing to say. My background is .NET and Azure. I'm one of the few people who's never really touched AWS, just by circumstance, not throwing shade or anything. I've worked in the banking industries, agricultural industries, obviously working in New Zealand. You're bound to meet some farmers somewhere, and also health and insurance industries. I'm also a former Microsoft MVP, and I used to work for Microsoft for a little bit, which was pretty neat. But we're not here to talk about me. Today, I'm going to cover what is Azure Container Apps, and I'm going to compare Container Apps to other serverless offerings in Azure and do a little bit of a comparison. Then we'll go into core concepts of Azure Container Apps, just really the fundamentals, and also the more serverless type of features that Azure Container Apps provides. This product has been generally available for just over 2 years now, and it has grown quite extensively because it is quite popular. So I'll just focus mainly on the serverless stuff, and I'll do a bit of a roundup around logging, security, secret management, a little bit of Dapper. Who here has heard of Dapper? I know you have, a couple of you, fantastic, awesome. And also do a bit of a comparison between apps and jobs, because jobs is a fairly new feature. So I'll just cover what jobs are in the context of container apps. Then we are going to tempt the demo gods by doing a demo. In conference Wi-Fi. There may be a load test involved. It may not work. It may work. Who knows? That's the fun. So serverless on Azure. What were the options before Azure Container Apps? The obvious choice, Azure Functions. Who here's worked with Azure Functions? Yep, a few hands in the room. That was really one of the first services I used in Azure. So executing code with event-driven compute and scale on demand and only pay for execution time. I've put a little asterisk there because it does depend on whether you're doing pure serverless on Azure Functions, or if you're putting it on a premium plan, or for the unlucky, unfortunate souls like myself, you're deploying it to application service environment, which is not serverless at all. There's also logic apps as well, the access database for applications, as it was told to me by a colleague who may or may not be in the audience, so I won't shame him, but that's true. But it's simplified event-driven orchestration workflows, again, fully managed pay-as-you-go. There is a offer called Azure Container Instances, where it was kind of serverless container management without managing the underlying infrastructure for those kind of quick startup times. And I've put AKS virtual nodes up there. AKS is obviously not serverless, but some of the kind of scale-out scenarios, you could actually burst out to something like Azure Container Instances just to do that kind of scale-out. However, there are problems with these options. So if you're using Azure Functions, it has a very opinionated programming model, a programming paradigm. You may not see it at the back, I do apologize, but that's a basic function that I'm actually running in production for one of my side projects. It has attributes, has triggers, it's very limiting on, it kind of enforces a paradigm onto you. And there's also limited first-class support for some languages. So if you think of the languages that it does support, C#, JavaScript, Python, the obvious ones that are missing are Go, and for Rust as well. You have to use custom handlers to manage that. Features such as Azure Virtual Network integration were missing. So as of Tuesday, there is now consumption, what they call flex consumptions, where you do have VNet integration, but that was missing for a long time, where you couldn't run consumption applications or consumption function apps in virtual networks. And stuff with logic apps, there was limited customization options. Container instances really struggled with scale, load balancing, and certificates weren't provided. And then with virtual nodes, yes, they are virtual nodes, but you still have to manage the underlying Kubernetes cluster. So enter Azure Container Apps, serverless containers for microservices, which was a nice marketing title that everyone seemed to love. Really, the purpose for container apps was Kubernetes was very hard to adopt for some enterprises. Lots of customers were complaining that the complexity of Kubernetes was actually a real blocker for adopting containers and also microservices application patterns. So what Microsoft did, they essentially brought out a new PaaS offering, Azure Container Apps, where they say, okay, we will manage all the AKS components for you, and we'll just provide a PaaS service for you to deploy your containers on, where you could actually focus on building your application, not managing the cluster, and then you can scale dynamically based on events. And some of the things that you can actually build with Azure Container Apps kind of really opened up. The obvious ones were microservices, where you could actually have the option to integrate with Dapper, if you needed to, and you can independently scale those using something called Cater, which I'll talk a little bit about later. Open up public API endpoints. Web apps was another example as well. That's not something you would host on Azure Functions at all, but with Container Apps, since it's just a container, you can containerize your web applications and deploy them there. Event-driven processing as well. Having queue readers, for example, processing messages as they arrive from the queue, and then being able to scale your container apps based on how many messages were coming into a queue. And another interesting one was background processing. So I may or may not have been involved in teams who have tried to do long-running background processing tasks on Azure Functions. It's not what it's designed for at all. Please don't do that. I've seen too many people try to do that, including myself. It's not what it's designed for. So Container Apps does provide that option as well. So let's dive into some of the core concepts that's kind of important to understand, how Container Apps actually works. So the first thing we talk about is an environment. So all your individual container apps are deployed to something called an environment, which is generally an abstraction of a Kubernetes namespace. You have your virtual network boundary around that environment. I'll talk a little bit about networking later, but essentially that could either be your own virtual network that you're deploying your environment to, or integrating your environment to, or it could be a Microsoft-hosted one, and they all write logs. All your applications will write, in an environment, will write logs to the same log analytics workspace. There are two types of environments available. So something called workload profiles, where you can actually run serverless applications alongside applications that run on customized hardware. So say if you have event-driven processing in some of your applications, you can run those in the same environment next to some applications that do long processing, background processing, or maybe machine learning workloads on them that kind of need dedicated hardware to run on. You can actually have that ability to deploy serverless applications alongside that. Or you could just go pure consumption. So you could just have an environment that just runs pure serverless applications. So with something like functions, that's not possible. With container apps, that is, which is pretty cool. And then within your environment, you have your container app. So a single container app will contain single services that include your desired state configuration. And then the containers themselves, rather than being limited by any functioning paradigm like Azure Functions, you can use any development stack of your choice. Currently at the moment, it is limited, or I should say rightfully limited, to Linux-based containers. People want Windows-based containers. Does anyone in this room want Windows-based containers? Anyone brave enough to put their hand up so we can have a robust discussion afterwards? There's a reason. I'm not trying to start a fight at the end of the day, I promise you. The reason why I say that is a lot of the fear at the time was people have all these .NET Framework applications, and we were working with those customers, and they were like, oh, Windows containers aren't that great on Azure Kubernetes service. It'd be great if we could deploy it to something like Container Apps, just because they didn't want to migrate or upgrade from .NET Framework to .NET Core. But, we reserve judgment. Yeah, so Linux-based containers only. It is on their backlog for Windows support, so hopefully they forget about it. Anyway, containers can come from any public or private registry, so you can pull images from public Docker, or you can hook something up like Azure Container Registries and pull your images from there into your container apps. You can run multiple containers in a single container app as well. That is an option. That's really for more advanced use cases if you're running sidecar patterns for your containers. That is an option, but generally it's advisable to have kind of just a single application for a single container. But you have the option there. We like options. Cool, and then revisions. So revisions are essentially immutable snapshots of your container app, and your container apps you have two choices. You can even run in single revision mode, which essentially every time you deploy a container, that's going to be the version that's made available to people who are trying to access your application, or a multiple revision mode, where that kind of opens up more advanced scenarios where you can do traffic splitting between different revisions. So you can do blue-green deployments, which I'm going to attempt to demo today if the conference Wi-Fi holds up. If not, there is a hotspot standby. Or you can do kind of A/B testing as well, which is pretty cool. Kind of comparable to deployment slots and something like function apps and app service. Here it's a little bit different, where it's kind of more of a snapshot version of your container app. So what makes it serverless? Well, it really comes down to how scaling works. And this is driven by replicas. So replicas are the unit of scale in container apps. So when there is support for scale to 0. And one of the cool things about multi-revision mode is that each revision of your application can have its own scale rules. So say if I deploy my application for revision 1, and I've got a limit of, say, five replicas, and I'm noticing that as customers are like hitting my endpoint and lots of traffic's being directed to it, and I'm constantly fine that throughout peak traffic and even low kind of unexpected traffic spikes, I'm always hitting 5. I can deploy a new revision of my application and define its own scale rules. So I can say I can have more replicas, or I can make my scale rules less sensitive, stuff like that. And scaling is supported by CADA. So who here has heard of CADA, or Kubernetes Event-Driven Autoscaler? A couple of hands in the room, fantastic. So this is an open source project, CADA.sh, I think is the website off the top of my head, and essentially this drives scaling of your containers based on event sources, otherwise known as scalers. So there are kind of built-in scalers that come with CADA. Some vendors have actually provided their own scalers. Some of them are vendor agnostic. There's scalers for messages for Azure Service Bus, HTTP scale rules or scaling, which I'm going to show you later on. I'll actually show you some examples in the next slide. So yeah, a whole bunch of different scalers. The important thing to note, that's a terrible color choice, I do apologize for that. Support for scale to 0 really comes from HTTP and event-driven based scalers. So stuff like consuming messages from Azure Event Hub, Service Bus, any kind of queue, GCP pub sub there. So it's got kind of all the flavors of the different cloud providers there, and also HTTP, you can scale to 0. You can scale on CPU and memory, but their support for scaling is kind of limited. That's in those situations where you can't actually scale to 0. You have to have at least one replica there. So that is a bit of a limitation. But you do have the ability to kind of scale depending on how much CPU and memory is being consumed. Cool, so container app jobs, I'll go through this really quickly. So container app jobs are a kind of a new feature that's kind of out. So your applications and services that really run continuously, and if it fails, the container app will actually go ahead and restart, where jobs are tasks, well, jobs are essentially tasks that have a start, run for a bit of time, and then exit when done. It's a single unit of work, and we can start those manually. We can run it on a schedule, like a cron schedule, or we can do that in response to events. And here's some examples of when we'd use one over the other. So you might have an HTTP server that serves API requests. That's more of an application use case there, and you can configure that on HTTP scaling. Or you might have a process that runs every night producing financial reports or any kind of reports, and you can actually run that on a cron schedule as a job. And like your container apps, the job will define the default configuration used for each job execution. They kind of live in the context of your environment. A typical job runs one replica, depending on the configuration, but it can also be shared across multiple replicas if needed. Some other things to keep in mind, logging. So Container Apps has several built-in observability features. It is very Microsoft heavy-based kind of observability out of the box, so log analytics, application insights, Azure Monitor. They have recently introduced public preview support for OpenTelemetry as well, which is pretty cool, something that I've been exploring a little bit. You can also do some real-time logging through log streaming, connecting to the console during dev and test, all those types of options. A little bit more about networking. I won't go into too much detail, but as I was saying before, all your container apps run in a container app environment, and the boundary around that environment is your virtual network. You have the option of having it generated for you, so that would live in Microsoft's tenant, so you do lose a little bit of control of that virtual network. But if you want to use your own virtual network, that's also an option as well, and also a preferred option for a lot of people that I've worked with, and also the applications that I've built as well. And this opens up more advanced networking configurations such as front door integration, NSGs, and private endpoints. Secret management as well. This is an area that's really been improved from the container apps. Before, it was just stored directly as environment variables, but now you can reference secrets from Key Vault, and you also have the option to mount your secrets from a volume as well. And then finally, there's Dapper integration. So essentially, one of the big pluses of Azure Container Apps is the support for Dapper right out of the box. If you're running workloads on AKS, you'd have to install Dapper onto your cluster and manage that yourself. Dapper is provided for you, and this provides like a whole bunch of APIs that you can use to build microservices, such as service-to-service invocation, state management, pub/sub, all those wonderful things that makes building microservices so easy. Everyone does it. Awesome. Let us, in the final 10 minutes or 5 minutes, tempt the demonstration gods. Cool. So what I've got here is a fairly simple application. What I'm going to do is actually, at the back, how is that? Yep, awesome, fantastic. So I've got two APIs and a web interface. So what I'm going to do first is I'm just going to show you this web application. Now, hopefully the internet will play nicely. It would play nicely in the speakers room. If not, this will be very, very interesting. But essentially, what I'm going to show you here, this web application has been scaled down to 0. So I can see that, yep, scaled to 0. So if I go into the overview and hit my endpoint there, that may take a bit of time to show up, but what we should see is a web application with some product information, so what the name is, what the manufacturer is, a unit price, and inventory. And it's essentially speaking to these two different APIs here. So, in the meantime, what I'll do, while that's loading and thinking about it, I've also got an API that accepts public ingress. Hopefully that should work. If not, because that's got one replica, I may need that hotspot assistance, but if not, just trying to think of how I can vamp while everything's loading up. Always works so perfectly when you're like in the speakers room. It's like, yeah, it works, it's fine. It's conference Wi-Fi, it's a little shady, but you know, it'll be fine, it'll work. Don't worry about it. When you get on stage, it'll be fine. Just relax, it'll be okay. Okay. So while that's loading up, what I'll show you is a little bit of infrastructure as code. Who here has worked with Bicep? If you're more in the Terraform world, you're looking at Bicep code for the first time, you'll realize a lot of it, or the concept has been stolen. I didn't say that. No, it's very familiar. It's very similar as well. So these are just resource blocks. So if I go down into, I think the things of note here, if I look at my Bicep file for my container app, here it's pulling from my container registry. I've got application insights in my environment. The things that I really care about in this are the scaling. So I'll actually look at my web one. That's a bit better. So when it comes to defining scaling rules, you can define a minimum amount of replicas and a maximum, so set those two limits, and then declaring like a scalar rule, a CADA scalar rule. It's just literally a few lines of bicep. So you do have the option of creating container app resources using YAML, if you're kind of coming from that Kubernetes manifest background. I love YAML, I'll be honest, but it can be challenging to work with, so that's just a simpler way of like actually building out those scaling rules for you. Ooh, so that's an error. Ooh, that's fun. So if I go into my revisions and replicas, okay, this is interesting. So what I'm going to do now, since it's given me that, I'm actually going to hit this directly. And while that's loading, I've essentially got this. This is all on GitHub, or my GitHub, which I'll share later. But essentially, this is a blue-green deployment that I'm testing out. So if I go into that workflow for that particular product API, essentially, get some more real estate going here. What you can do, you can actually use the AZ CLI to create revisions for you and also set the amount of ingress a particular revision is going to get. So this kind of line here, with blue-green deployments, it's essentially you're switching between revisions. So here, as I'm creating a blue slot, I'm assigning 100% ingress to that. So when I go back into my portal, I can see that these two different revisions, these two are running, or they're all running, but 100% of traffic is being allocated to that green slot. So no traffic is being hit to this one from the public internet, but I can access it directly through this revision URL, so each revision gets its own endpoint. So if I open that up and go into products, I should see there's a unit price there. And if I go back into the one that's receiving 100%, I should see that unit price with nothing. I don't know why you're giving me that. Just looking at the time. That's unfortunate. Never mind. But anyway, what you can do is you can actually review that. I'm going to promote that to the blue slot. And then if my application was working, what I might do, I'm actually going to go into my web application, look at my revision and replicas, and let's see how many replicas are running. So only one replica is running at the moment. I will give this one attempt before I give up. I know it's almost beers o'clock. Nope, getting internal errors. That's okay. So what we should have seen is a nice Blazor web UI, but that's okay. What I'm going to do, I'm going to rerun this. I'm going to rerun that. That's going to start my load test for me. So that's provisioning, it's going to execute. And what I was doing earlier is essentially you can actually look at your container app logs and get some details from a system level and also a console level as well. So if I hit that, it should be able to show me the logs in real time and also show me how many replicas are running and how what replica count is running. Hopefully. If not, it's fine, it's okay. All the code is on GitHub, so you are able to have a play around of it. That's not what I want. So I know my API is working, which is good. It's just my web that's not working. Let's have a look at that. Load test. It's provisioning. That test will start shortly. Lies. So that's been successfully deployed. So if I go back into my product API, we should see that the traffic is now at 100%. So there we go. Oh, it failed. That's fun. So now because of that blue-green deployment, essentially the update that I've made to my application is now receiving 100% of the traffic, which opens up some really cool scenarios so you can run some integration tests in there against a revision, but no traffic's been run against it. So you can do that kind of blue-green deployment. Cool, I'm gonna give this one last go. One last hopeless go at the end of a long day in front of all you fine folks who have spent your Fridays listening to some awesome talks only for it to be destroyed by my... There we go, awesome. So, just pretend that nothing happened in that unit price and it was all null and you were like, oh, that's silly. Why would you not have any information there? What the blue-green deployment was supposed to show is like you can have this running, but hitting one API and then you can do some testing and it was all supposed to be all brilliant and fantastic, cool, whatever. Fantastic. Now, because I'm feeling a little bit cocky, that is executing. So now what I'm going to do, I'm going to go into my revision and replicas. Let's have a look at my terminals, anything happening. So I'm still on one replica. And I've got a max defined of 10. Now, a nice way that you can look at it through the GUID, I can see 10 replicas there, so maybe my logs are getting a little bit delayed, but then you can see all of these replicas are now being spun up, and you can kind of drill down into these. You can do this programmatically. It's better if you do it programmatically. I'm just showing it through the portal just to make it nice and clean for you. Awesome. So that's a little bit of scaling, a little bit of revision management, all wrapped up in a glorious mess. I hope that kind of made sense. If it didn't, come and talk to me afterwards at the after party and we'll have a good discussion. Awesome. So to wrap this up, we talked a little bit about, that's not working, I forgot about it. We talked a little bit about what Azure Container Apps is, compared it to other serverless offerings. I think you have a lot more control, particularly over the programming model that you're using. Your deployment is very much the same like you would do with other applications as well. I think it's a little bit more aligned. Functions had a little bit of differences that here and there, which were okay for your easy integrations. I'm trying really hard not to just downplay Azure Functions. It's great for those simpler scenarios, but Container Apps does provide a little bit more out of the box for you. Talks a little bit about core concepts, the difference between jobs and apps, how scaling works, and everything else. I've been Will Velida. I'm Will Velida all pretty much online. I'm the only Will Velida that I know, which is good. If there is another one out there, please let me know, especially if he's up to no good. I'm on YouTube, LinkedIn, Twitter, and GitHub. Thank you all for listening.
All right. Thanks, Will.